Hello everyone, I'm Gang. Okay, please remember to watch section 2. There's quite a bit of content in section 2, but let's go through it all at once first, and then I'll give you a hands-on demonstration. Okay, in this part, it mainly involves adding our character class and then writing some C++ code within it so it can respond to the mappings, while also adding some assets. Okay, let's first take a look at the content of this lesson. It might be a bit much, but that's okay. We'll still finish explaining it all at once. Then we'll do a hands-on exercise. Okay, this is what this lesson covers in terms of functionality, and it's roughly divided into these 8 steps. First, in this part, ACJudge class was created, and this C++ class inherits from our character. Then after inheriting from character, we confirm its creation, location, which is right here. And in this place, in the character section, it is in its begin play, under this method. It has added this, meaning that when this actor starts, it will prompt us that our actor has been spawned, and this is the code for the actor that has been created. Then at this point, after we directly launch it, we can turn off this level editing. We don't need to use this level editing. It will bring us some potential issues. Then in this place, after having the C++ class, we create its subclass. When creating the blueprint, you will find it has many default components it provides. These default components have corresponding functionalities. We will expand it after we create it later. And at this point, we need to specify the blueprint character class we created as the default blueprint class to use. This way, when we spawn it, it will generate and give it to our player controller. When a player enters, it will spawn this character class for them. Now we need to set up the input mapping. It's very simple and clear. First, we set up the axis mapping. After setting up the axis mapping, we set up the basic movement. That is, but note here, it is bound here. This U function is written. Yeah, then this place needs a U function. Special attention should be paid to the U function here. That is, collisions often occur when overlapping, cannot collide, cannot overlap. Obviously, the function you bound is not triggered. Then consider whether you missed this U function. Yes, that's it. Then there are true U functions here. Now implement an association for it. And this place is the same as our previous method. It is to bind the front-end mapped keys in the movement component. Then just bind it on. So when we execute it, we are called the AddMovementInput. What is this method? This method is actually the method inside that character. It essentially adds our input vector to the movement of the main character. It's just encapsulated here. We'll take a look in a moment and we'll see. And then this one is for move right, which is for the other direction of movement. After adding it, the code looks like this. Actually, just a quick glance is fine. Then compile it at this point. Let's build it. And then at this point, you can actually start moving. Then here, he adds the mapping for this turn axis. Actually, it's adding the input for our mouse. Then we can rotate the camera. So he also added TOR here. And in the turn section, he maps the X and Y axis respectively. Actually, it's to map its two axes. One is for looking left and right, and the other is for looking up and down. To perform the mapping, we generally do not map another axis. That axis would be equivalent to rotating the screen rather than being a row axis. Yes, we usually only modify this pitch. Pitch is this up and down roll, and then the yaw value is this left and right rotation. This roll value is actually this kind of rolling axis. Yes, okay, then here we perform a simple binding back. Good, it's bound now. Then after binding, it binds these two yaw input and pitch input here. Then next, it seems it hasn't written the code for this yaw and pitch input. We'll see once we check it. Then compile here. After that, we can control our camera with the mouse. Then here, implement the character's jump. So that's actually our action mapping. It uses spacebar here, and here it is. But note that there are two here. One is start jump. One is release, because it wants continuous jumping. That is, after jumping, land and then jump again. Land and then jump again. So here, there are two functions. Then here, we can see. Here it is through this Boolean variable. This Boolean variable is the one in our character class. Because the character class helps us, generally, we commonly use it for humanoid, NPCs or player-controlled characters. It has already written some basic property variables for you. You just need to modify them. This places binding and input for it. After binding, it looks something like this. Actually, it seems here. We'll take a look at this method in a moment. This method is missing. Or does it have this method inside? We'll know after taking in a moment. That is testing the jump. And now you can jump. Actually, you can't really tell right now. Although your capsule is moving, we actually need to give it a static mesh. You can download this static mesh from this location. It has already been downloaded here. Then you use the standard import format for FBX input. Actually, there are many details when importing here. Specifically, you need to check the blueprint tutorial. Sometimes we import some morph targets, or when importing animations, we can check some options. Only import the parts we need, because, FBX is a very complex asset format. It can contain a lot of things. You only need to import what you need, but if following the standard, maybe just the one is enough. Then save the import plan carefully. Then we specify our Google Grid problem through mesh. We call it skeleton mesh. No issues here. Then here we modify its position. Okay, this is also fine. Then this is done. Then we have our static mesh. Then we can from debug, press F4 or use this. It pops up, right? That is the debug control we use. You can also see that our player character looks like this. And here, a camera has been added, because you will notice that if we haven't added a camera yet, it might automatically generate some cameras for you. So here, the character has added a camera component. And in this camera component, we have actually created a camera. Then we attach it. At the same time, we need to adjust its position. We want it to be first-person perspective. We adjust the position to this height. This BaseEyeHeight parameter, once this parameter is added, it will work. These are also some parameters within it. Then this place allows this. That is to say, this pawn can control the rotation of the camera. And you can set the default child. If you have changed the default child, then you may need to reset it to the default child for it to respond to your last modification of the default child. After writing it, the code will look roughly like this. Okay. Then this place is under compilation. Let's take a look at this new camera, what it looks like. Good. Then let's continue looking down. Then at this point, it needs to process the first-person mesh, because when others look at you, it's in third person. But when you look at others, it's actually in first person. So at this point, it creates another arm, an arm that only we ourselves can see. So this is the arm it created for the first person. Then here we have a rendering visibility option, which is to let only the player who owns it see. Okay, and finally, we set it up like this, meaning the owning player cannot see it. No say. So this method is used to create the can't see yourself in third person, can only see yourself in first person. That's the setting. Then after looking at it, that's basically it. Yes. If you look, this is the problem caused by leave encoding. That is, if you enable leave encoding, this might be the issue. And at this point, in this place, it may need to import an asset. It looks at our position. Where is it placed? It's right here. Just this asset. Import it. Similarly, we'll assign it again at this position. After assigning leave it alone, then at this point, after setting it up properly, then we assign it here, this first person thing, then put this hand on it. Now we need to adjust its position. The position is now adjusted. When running later, we can see the first person effect like this. So that's roughly what this chapter is about. That's quite a lot. There might be 8 sections. We will implement them one by one for everyone. Then the important thing is to take a look at this. Okay, then we'll stop here. We'll implement this in the next class.